This is Algebra 1, and we're going to talk about counting principle and permutations. So first, there are some real-life problems that you may want to count the number of options you have. And the first way I'm going to show you is to do a tree diagram. So we'll start with my favorite, ice cream. So you go to an ice cream store and they ask you what kind of cone you want. Do you want a cake, do you want a sugar, or do you want a waffle cone? So that's our first choice. So let's go ahead and start with that. So we'll just call the cake, oops, let's get this to work here. We'll say cake, sugar, or a waffle cone. Now that you've chosen your cone, you can choose between chocolate, vanilla, just chocolate and vanilla, okay. Chocolate or vanilla, chocolate or vanilla, chocolate or vanilla. Okay, so how many different ways can we make ice cream cones? It looks like we have 6 possible combinations we can have. Right. A shortcut to do that is use something called the fundamental counting principle. You may not want to draw a diagram every time. So what you do is you multiply the number of choices for your first option. For us, that was our type of cone. There were 3 types of cone. And then you multiply that times the number of different ice creams. We only had 2. If the store had 50 different ice creams, you wouldn't want to diagram it every time. So 2 times 3, we see there were 6 different ways we could create our ice cream cone. So now let's just add something on. Say maybe on our ice cream, we were trying to decide between sprinkles or a chocolate dip. So let's go back. So we'll use the same thing. From this one, we have sprinkles or a dip, sprinkles or a dip, sprinkles, dip, sprinkles, dip, sprinkles, dip, sprinkle, dip. You can see that would get pretty tedious. So we're just going to add on to what we already had. We had 3 types of cones, 2 types of ice cream, and then 2 types of topping, assuming that we were definitely going to choose a topping. So now we're 3 times 2, which is 6, times 2 is now we have 12 possible different ice creams that we can choose, we can create. All right, your turn. You're going on vacation, you pack 3 pairs of shorts, 5 shirts, and 2 pairs of shoes. How many different outfits can you create? If you want to, you can diagram it. Shorts 1, shorts 2, shorts 3. To the shorts, you can do your 5 different shirts. You can see that's going to take a while. So you might want to use our new shortcut. We have 3 pairs of shorts, 5 shirts, and 2 shoes. 3 times 5 is 15, times 2, it looks like we have 30 different outfits we can create. All right. When you order objects, where order matters, it's called permutations. Okay, so let's order the letters A, B, C. So it could be A, B, C, or it could be A, C, B. Let's start with B. It could be B, C, A, or B, A, C. And let's start with C. We can have C, A, B, or C, B, A. Okay, it looks like we have 6 different ways we can arrange the letters A, B, C. And you can see how that get pretty tedious if we have more than 3 letters. So we're going to use the fundamental counting principle to arrange those. So the first option, the first spot we had, how many different letters can go in the first spot? A, B, or C. It looks like we had 3 that could possibly go in the first spot. Now that our first spot is filled, we only have 2 options for the second spot. And now that we filled the first spot, we filled the second spot, there's only 1 letter left. So there's only one way we can arrange that. So we take 3 times 2 times 1, and we get the 6 without having to diagram them all. When you multiply something starting at that number all the way down to 1, that's called factorial. And the symbol for that is an exclamation point. So if you see something like this, that's read 3 factorial, which means it's 3 times 2 times 1, which is what we just did. And there's a button for that on your calculator, and I'll show you how to do that. Okay, there are 10 kids in your class playing Kahoot. How many different ways can those kids finish the competition? So order does matter. There's a first place winner, a second place winner, etc. So we know the first spot can be won by 10 different kids. Now that somebody took the first place, there's only 9 kids that take the second place. Now that those 2 spots are full, we get 8, we get 7, 6, 5, 4, 3, 2, and then 1 in the 10th position now that those spots are full. And again, that's called 10 factorial. And you can simply punch in your calculator 10 times 8, 9 times 8 times 7, etc., and you'll get your answer. A shortcut is to use that factorial button. And on the TI-30s that we use in class, it's under the probability key. It's the upper left-hand side. It's PRB for probability. You punch in your number, which is 10 in our case. You punch in your PRB button, probability, and you arrow over till you see the exclamation point. Press equals and equals again, and it tells us this is a big number. It tells us there are 3, 6, 2, 8, 8, 0, 0. I guess that's 3,628,800 different ways that your class of 10 can come in different orders in playing Kahoot. Now let's just say, hey, we're worried about the top 3 winners. They're going to get candy. So how many people can take the top spot? 10, of course, right? And after the top spot is taken, how many people can come in second? 9. How many people can come in third? So number's a little bit more manageable. So we're going to multiply 10 times 9 times 8, and it looks like there's 720 different ways we can have 10 people take the first 3 spots. Okay, let's try it. You have 6 Jolly Ranchers in your treat bag. How many different ways can you eat those 6 candies? Again, order matters. Which one did you eat first? Which one did you eat second? If order doesn't matter, that's a whole different thing. We'll talk about that next week. So the first candy you ate, there's 6 different flavors to choose from. Now that you ate one, there's only 5, 4, 3, 2, 1. We know how to do that now. That's our 6 factorial. You can punch that in your calculator that way, or you can use that little factorial button under probability. And it looks like there's 720 different ways you can eat those candies. Now say you only eat 3 of them. You want to save the other 3 for later. Remember, you have 6 to choose from on the first time. Now that you ate that one, there's only 5 to choose for the second one, and 4. So 6 times 5 times 4. It looks like there's 120 different ways you could eat those candies if you're eating just 3 of them. Okay. Now, of course, there's a shortcut. You knew this was coming, right? It's called permutations, and it's in your calculator. And I think I cut off part of it. So it's NPR. N is the total number that you have. In our case, we had 6 candies. R is the number that we're going to eat. We were going to eat 3 of them. Okay, and again, order matters. Which one do we eat first? Which one do we eat second? So there's a button in your calculator. Again, it's under probability, the PRB. First, you punch in how many candies you had. We had 6 candies. So I punch in a 6, and then I press my probability button. And the first one that pops up is permutation. And then I just punch in how many candies I was eating. I was eating 3, and it tells me it's 120. Okay, so the first button is how many you have. Then the last one is how many you're going to take. In this case, how many candies we ate, and we had 120. Let's try it again. You have 12 songs on your playlist, and you can listen to 3 of them. And again, order matters. Which one did you want to listen to first? Which one do you want to listen to second, third, etc.? So we're going to use the shortcut just to try it. We have 12. We're going to take permutations 3 at a time. So I'm going to punch in a 12 in my calculator. I'm going to press the probability button. I'm going to get permutations, and I take 3. And if you're saying, hey, I don't have a calculator or I can't find that button, that's okay. Just take 12 times 11 times 10. You know how to do it. Take the first 3 numbers of 12, and you're still going to get the same answer, which is 1320. I just want to talk about one thing that you have to talk about. What if you don't decrease the options? Okay, what if you can repeat something? Say you're getting ice cream and you choose you want 3 scoops of chocolate. Okay, you know how I say you start at the high and you decrease just like the winners? You don't want to decrease. And again, order matters. I want to know what's my first scoop, what's my second scoop, okay? If order doesn't matter, we'll talk about that next week. So it looks like we can choose from chocolate, vanilla, cookies and cream, butter, pecan, and strawberry for a triple scoop of ice cream. So how many choices? It looks like we have 5 different ice creams. How many choices on the first scoop? 5. How many choices on the second? Again, we can repeat if we want. So that means we have 5 again. We don't have to go down to 4. And the third scoop, we can repeat again. So we're going to take 5 times 5 times 5. Or if you're okay with repeating, there's 125 different ways you can make your ice cream cone. Okay, please try the practice problems. Let me know if you have any questions. Thank you.